Welcome to our YouTube channel. This is Ernest coming to you from MathLab Tutorials in Toronto, Canada. Our mission, impossible sometimes, is simply to convert some of that math hate to math love. As your screen says, like it or not, math really did take us from the Flintstones era to the Jetsons era. Now let's get down to some serious math. This is video 4 of the BEDMAS series, and as your screen indicates, we're going to be doing some operations with fractions. And I know fractions are not well loved by many people, but they're a necessary evil. Personally, I love them myself. I'm not in love with decimals. I prefer fractions. I think the majority of mathematicians prefer fractions over decimals. When dealing with decimals, often you'll get repeating decimals that we don't like because we're going to have to round at some point. Or we get irrational numbers, which are non-periodic decimals. And anyway, they're a mess. Okay, the best thing to do is to actually start learning how to deal with fractions. So let's get the ball rolling. Part A deals with addition. Again, the positives are good guys. So we have positive fractions are good guys, and negative fractions, we're going to refer to them as bad guys, just like we did with integers. So there are good guy fractions and bad guy fractions. The bad guys are negative and the good guys are positive. Little note to start off with. Formal definition of a fraction. A fraction is of the form n over d. N is called the numerator and d is called the denominator, where both n and d, numerator and denominator, are both integers. And you'll recall that integers are plus minus 0, 1, 2, 3, etc. So in other words, a fraction is an integer divided by another integer. And that's what constitutes a fraction. The only problem is that the denominator can never be 0. Okay, that does not qualify as a fraction. So beware of that. The denominator must not be 0. Otherwise, we call the fraction undefined. So for the time being, we'll just leave it at that. Make sure denominators are not equal to 0. Otherwise, the fraction will be undefined. Otherwise, the numerator could be an integer. The denominator could be an integer, as long as the integer in the bottom is not equal to 0. So again, over here, if we look at the bottom, we have n over d. When you look at n over d, if the fraction n over d is between -1 and 1, that's how we indicate between -1 and 1. Strictly between -1 and 1, in other words, not equal to -1 or not equal to 1, then it's called a proper fraction. Of course, examples of proper fractions are like 1 over 3, which is between -1 and 1, -2/3, which is between -1 and 1, 3/4 between -1 and 1, etc., etc. When the fraction n over d is less than or equal to -1, or the fraction is greater than or equal to 1, then the fraction is called improper. And we usually convert improper fractions to mixed fractions. This is usually done in the elementary grades. They teach you how to do this in elementary school. But from a practical perspective, improper fractions are fine, and there's really no need to convert to a mixed fraction. But again, it's your option. You can leave an improper fraction as improper, or you can convert to a mixed fraction if that tickles your fancy. Okay, personally, I prefer improper fractions to mixed fractions, but I guess it's a matter of choice. Okay, so again, a proper fraction is any fraction between -1 and 1 excluding -1, excluding +1, and any improper fraction is either less than or equal to -1 or greater than or equal to 1. Okay, so let's go on to the next slide. Here's some examples of proper and improper fractions. The fractions under column 1 are proper. 1/2 is between -1 and 1, so it's proper. -1/2 is again between -1 and 1. 2/3 is between -1 and 1, and -3/4 between -1 and 1. Okay, we notice that in each case the numerator is smaller than the denominator. The numerator is smaller than the denominator in each case. The positive or negative in front of the fraction has no bearing on whether it's proper or improper. Again, an improper fraction, it can be converted to a mixed fraction if you want. 3/2 is called a mixed fraction or an improper fraction. Notice that the numerator is larger than the denominator. And if we did a long division on this improper fraction, 2 goes into 3 once, and then you get a 1 remainder. So it becomes 1 and 1/2. 4/3, if you do a long division, 3 goes into 4 once, and then you have 1 remainder. So we could rewrite that as 1 and 1/3. -7/5. 5 goes into 7 once, and again you have 2 remainder, and so you can rewrite that fraction as -1 and 2/5. That would be the mixed fraction version of this improper fraction. And -3/2, again 2 goes into 3 once with 1 remainder, so you can rewrite it as -1 and 1/2. Again, I prefer improper fractions to mixed fractions. They're easier to deal with when trying to simplify certain expressions. Mixed fractions are just a bit of a pain. Okay, so let's go on and do some problems. Oh, actually, before we do some problems, we need to discuss an important concept called the lowest common denominator. LCD for short, lowest common denominator. Sometimes the lowest common denominator is also called the least common multiple or the lowest common multiple. But because we're dealing with fractions and we're used to denominators, then we'll just call it the LCD for the lowest common denominator. And the LCD of two numbers A and B, that's the way you pronounce that, the LCD of A comma B, is the smallest number such that both A and B divide into that number evenly. In other words, it's the smallest numbers that is divisible by A and divisible by B simultaneously. Okay, so let's look at some LCD examples. The LCD of 2 and 4 is 4. Why is that? Because 2 goes into 4 evenly, 4 goes into 4 evenly, and 4 is the lowest such number. Okay, the LCD of 2 and 3 is 6. Why? Because 2 goes into 6 evenly and 3 goes into 6 evenly, and 6 is the lowest such number. The LCD of 2 and 6 is 6. Why? Because 2 goes into 6 evenly and 6 goes into 6 evenly. And again, 6 is the lowest such number to do that. The LCD of 4 and 6 is 12. Why? Because 4 goes into 12 evenly and 6 goes into 12 evenly. And again, 12 is the lowest such number. We can also do the LCD of three numbers, 2, 4, and 6. The LCD, if you look at that carefully, you'll see it's 12 because 2 goes into 12 evenly, 4 goes into 12 evenly, 6 goes into 12 evenly, and again 12 is the lowest such number. The LCD of 3, 4, and 8 is 24. 3 goes into 24, 4 goes into 24, and 8 goes into 24 evenly, and 24 is the lowest such number that does the job. These days, modern calculators will actually calculate LCDs of numbers for you. You just have to have a good scientific calculator. There are processes in place to calculate LCDs of large numbers, ones that you can't easily guess, but we won't look at those right now because that's not really the idea right now. The idea is to use the lowest common denominator and to pretty well guess what the LCD might be, rather than go through a formal procedure on how to find the LCD, especially if the numbers involved are quite large. Okay, so let's go ahead and deal with the next problem. Actually, this will be the first problem, Q1. Use the LCD to find the result of the following fraction string. You remember we started the BEDMAS series with integer strings, and now we can talk about fraction strings. We actually even had cases where we had cluster strings. Okay, so now we're going to be talking about fraction strings. And a string just means that it's one term after another, after another, after another, side by side. So over here we have 1/2 plus 3/4 plus 5/6. Notice the fractions are all good guys because they're all positive. So we have 3 terms, and the LCD of the denominators, 2, 4, and 6, is 12. And this is how I go about adding fractions. What I do is put a big division bar here, leave the numerator empty, put the LCD on the bottom, the LCD that you found over here, put it on the bottom, leave the top over here empty. Then look at all the numerators, 1, 3, and 5. And what I do is bring the 1 down and do a dot empty bin. Bring the 3 down, do a dot empty bin. Bring the 5 down and do a +5 dot empty bin. Leave these bins empty for the time being. Now the job is to try to fill in the bins. The easiest way to fill in the bins is do LCD divided by each denominator. We get 12 divided by 2 is 6, fill in the bin. 12 divided by 4 is 3, fill in the bin. 12 divided by 6 is 2, fill in the bin. Now all those empty bins are full. When we look at the numerator now, all it is a string of essentially 3 terms. And all we have to do is evaluate each term and add up each term in the string. So we see that we have a 1.6 is 6, and 3.3 is 9, and 5.2 is 10. Of course, the 12 gets dropped down in the denominator. Now, these are all good guys, so all you do is add them up. When you add them up, you get a 25. So the final result is 25/12. That's improper. If you want to convert it to a proper fraction, to a mixed fraction, then 12 goes into 25 twice with 1 remainder. So you get 2 and 1/12. And that's the mixed fraction conversion of the improper fraction, 25/12. So that's a fairly simple example. Let's go on to the next slide. Let's look at Q3. It says use the LCD to find the result of the following fraction string. If we look at the string, it's 3/4 minus 7/2 plus 5/3 minus 1/6. The difference now is that we have 4 terms to deal with, and some of them are good guys and some of them are bad guys because some of them are positive fractions and some of them are negative fractions. But we don't worry about that right now. Our job right now is to look at all the denominators. The denominators are 4, 2, 3, and 6. So we conclude that the LCD of 4, 2, 3, and 6, if you work that out, it's 12. You can do it by guessing if you want. It's the lowest common denominator. Why? Because 4 goes into 12 evenly, 2 goes into 12 evenly, and 3 goes into 12 evenly, 6 goes into 12 evenly, and 12 is the smallest such number that does that job. So in the next line, what you do on your paper is draw a big fraction bar. Put the LCD on the bottom, and what we're going to do is drop the 3 down, do 3 dot empty bin, minus 7 dot empty bin, plus 5 dot empty bin, minus 1 dot empty bin. And the objective now is to fill in those bins. I know they're full right now, but pretend like they're not. Okay, now what do we do to fill in the bins? Of course, we're going to do the LCD divided by each denominator. So when we do 12 divided by 4, we get 3. Drop it inside the bin. 12 divided by 2, you get 6. Drop it inside the bin. 12 divided by 3, you get 4. Drop it inside the bin. 12 divided by 6 is 2. Drop it inside the bin. You look at that numerator now, and you have a string on your hands. We've seen plenty of these strings in the past, so it's easy to evaluate the string. We have the know-how. In the next line, draw a big division bar, put the LCD, which is 12, on the bottom, and we'll start evaluating the string. We know that 3.3 is 9. Over here, the neg count is 1, so negative 7.6 is minus 42. Over here, 5.4 is 20, so we drop into plus 20. And negative 1.2 is negative 2 because the neg count is negative. The neg count is 1. Okay, so negative 1.2 is negative 2. And then, of course, the denominator goes on the bottom. Next thing you do is group the good guys and the bad guys in the numerator. We have 9 plus 20 is 29, so we have 29 good guys. And 42 plus 2 is 44, so we have 44 bad guys. And then we notice that in the numerator over here, the bad guys win, so you put a minus sign down. And then you do large minus small. 44 minus 29 is 15. And of course, the LCD goes on the bottom. Now, 15 over 12 can be reduced. Why? Because we know that 3 goes into 15 5 times, so we put a 5 down. And 3 goes into 12 4 times, we put a 4 down. So this 15 over 12 reduces to 5 over 4. And of course, that minus sign just gets dropped down over here. Now, minus 5 over 4 is an improper fraction. At the end, if you really want to convert to mixed fractions, you put the minus sign down. 4 goes into 5 once with 1 remainder. So you get minus 1 and 1/4. And that's your final answer in mixed fraction form. Let's go on to the next question. This is Q7. Again, it's an LCD problem. If you look at this carefully, we have 4 fractions. Some of them are positive, some of them are negative. So we have 4 terms. And we look at the denominators. The denominators are 2, 3, and 5. We conclude that the LCD is 30. The lowest common denominator of 2, 3, and 5 is 30. You can easily verify that. In the next line, you draw a big fraction bar, a long fraction bar. Take the LCD, put it on the bottom, and then look at all your numerators. You drop the 3 down, so you do 3 dot empty bin, negative 1 dot empty bin, plus 2 dot empty bin, minus 1 dot empty bin. And now we're going to fill in the bins. We do 30 divided by 2 is 15. Drop it inside the bin. 30 divided by 2 is 15. Drop it inside the bin. 30 divided by 3 is 10. Drop it inside the bin. 30 divided by 5 is 6. Drop it inside the bin. So now in the numerator, we have a simple string that we need to deal with, just like the last question that we did. So that shouldn't be an issue. 3.15 is 45. Negative 1.15 is negative 15. 2.10 is 20. Negative 1.6 is negative 6. We have an integer string here. We know how to deal with that. So that shouldn't be a problem. So that equals, we have 45 good guys, 20 good guys, 65 altogether. We have 15 bad guys, 6 bad guys. We have 21 altogether. The good guys win. So the result is positive, and the good guys win by 44. So at the end, we get 44 over 30. And you'll notice that this not only is an improper fraction, but it can be reduced. We notice that 2 divides evenly into 44 and divides evenly into 30. 44 divided by 2 is 22, and 30 divided by 2 is 15, and then 22 and 15, they have no common divisors, so that must be the reduced fraction. And again, it's improper. We can go to a mixed fraction. 15 goes into 22 once with 7 remainder, and we write down 1 and 17, or 7 over 15, as the mixed fraction equivalent of 22 over 15. Let's turn to the next slide and let's see what's going on. And I think what we're going to do is reserve this for the next video. Thanks to all for viewing this video. Stay tuned for many more to come. If you liked the video, please give us a like and subscribe to our channel. If not, tell us how to improve it. Over and out for Math Lab Tutorials in Toronto.